We know in maths the fundamentals of BODMAS override everything that we do that involves number work and numeracy with what we're looking at. What I want to look at in this video is I want to look at multiplication when it's applied to both fractions and mixed numbers, and how we perform the calculations that are involved here. Now, when it comes to either of these types of numbers, fractions or mixed numbers themselves, what we have to do is remember that there is actually one simple, straightforward, fundamental rule that we can apply when we're doing the process of multiplication between the two. That simple rule is that we multiply the numerators and we multiply the denominators together. No more, no less. Bear it in mind in that manner, that's how we do it. Now, a question like this can be presented generally in a couple of different ways. For example, one way could be to present the question as a half times 3 over 4. Another way that the question can be represented is having it written in the manner as a half of 3/4. Now, both of these mean the exact same thing. There's one thing I want you to remember. If you get version 2, which is this version here with a half of 3/4, the first thing I want you to do is rewrite the question out straight away and replace the word of with a multiplication. Because remember, they both mean the exact same thing, and if we get rid of that of, we can remove that level of confusion straight from there, and what we're then able to do is just go forward with a simple calculation. So let's imagine we've got it here like this, and we're going to follow that simple rule. What we're going to do is we're going to take the numerators and multiply them together. We're going to take denominators and multiply them together, and that will give us a new fraction. So our numerator is going to become 1 times 3, which is just 3, and our denominator is going to become 2 times 4, which is 8. So a half times 3/4 gives me 3 over 8, or a half of 3/4, as it's put in the other way, is 3/8. It's a fairly straightforward calculation to do, and it's a fairly straightforward calculation to follow through on. However, there's also one other fundamental rule we always have to remember, and it universally applies to fractions across the board, whether we're doing operations with them here, whether we're writing down fractions, whether we're looking at equivalent fractions, or anything like that. There's always one rule we have to follow with fractions, and that's that we always simplify. Now, when it comes to simplifying with operations of fractions, such as multiplication here, there's actually 2 stages that we can do. There's 2 ways that we can simplify them. Imagine I had the calculation 2/5 times 10 over 60. Now, there's 2 ways I can approach this calculation, bearing in mind that I always want to simplify my solution. The first method is to simply do the operation as we described a moment ago, and then simplify at the end. So for this one, I'd multiply the tops together. 2 times 10 is 20. I'd multiply the bottoms together. 5 times 16, that gives me 80. What I can then do is say, right, I need to simplify 20 over 80. Well, I know that 20 is a common factor of both. So if I simplify that, I'll end up with 1/4. There is a second way to approach it, and this way is much more useful if we have really, really big numbers in particular. And what we can do is simplify before we do the calculation. And we can simplify before we do the calculation by looking at going across the way. If we simplify across the way with common factors, what we're then able to do is do the calculation in the next step, and then work at a slightly simpler form of the calculation. So if I was to look top left to bottom right, I'd say 2 and 16, 2 is a common factor, so that'd become 1 over 8. If I was to then look bottom left to top right, that would be 5 and 10, so that would be 2, and that would be a 1 there. So then it quite simply becomes essentially 1 over 1 times 2 over 8, which gives me 2 over 8. Then I can say 2 over 8 simplifies to 1/4. I could have done a simplification here at 10 over 16 and started with that step as well. That would have then taken another layer out of the process. Bottom line is, for both of them, I've simplified the final answer and I've got to a quarter. Right, here's your turn. I'm going to put a couple up. Pause it, have a crack at them. See what you think. So we've done these ones here. What I'm going to do is I'm going to tell you for this one here, same process, multiply numerators, multiply denominators. You get 21 over 40. The second question here, again, I could multiply the numerators and get 72, multiply denominators and get 150, and then I'd simplify that one down, and I'd end up with 12 over 25. Now remember I said I could have simplified it at the start by cancelling diagonally. I could have made that a 3 and a 5, and I could have then made that a 5 and a 4, and it would still have got to the same final answer. And the last question here is a 3-step process. Now this one can be done by doing any pair of fractions and then taking the solution and multiplying it there, or I could have done the whole thing in one step. So doing my numerator, 6 times 8 times 11, my denominator, 6 times 5 times 4. Performing this will then give you 528 over 140. Now that simplifies down to give me 132 over 35. And if the question wanted a mixed number, what I'd end up being able to write that as is 3 and 27 over 35. Same process for all three of them, multiplying things together and getting your solution at the end in the simplest form. Now this last one leads me on to an interesting thought. I ended up with a solution that was a mixed number. What happens if I'm going to multiply two mixed numbers together? What happens with the process then? Because now I've got a whole number part and I've got a fraction part when we multiply together. Now logic dictates, put the numbers together, put the fractions together, get a final solution out of the whole thing. Well, actually, that doesn't work. That gives us the wrong solution in the process. When we have a mixed number and we're multiplying them together, our first step has to be to turn the mixed number into an improper or top-heavy fraction. So if I had this calculation here, 3 1/4 times 2 3/5, I'd actually have to make that into 13 over 4 times 13 over 5. I'd have to make the process into that. Now 13 over 4 times 13 over 5, I would then be able to follow the process that we talked about just a moment ago. So I'd end up with 169 over 20. I could then simplify 169 over 20. Now in this case we can't do it directly like this. However, I could make it into 8 and 9/20. So I could turn it back into a mixed number at the end. Now, a key thing to remember is depending on the question, it may ask you for a set format in the solution. So it may ask you for a mixed number or an improper fraction. Whichever version it wants, make sure you give it. If it doesn't ask you for it, either of them is fine. It'll just make your life easier depending on what you're doing next as to what format you pick. So here's another couple for you. Pause the video and have a go at them, and I'll show you exactly what to do when you come back. So you've had time, you've had a crack at these ones, so let's look at them. So this first one here has just a fraction and a mixed number. With a 3/5 we don't have to do anything to, but you have to follow that rule I said a moment ago for the 1 7/8. What we do is we turn that into 15 over 8. So I'm going to multiply the two of these together. Now again, I can simplify diagonally if I notice. So I could take the 5 and make that a 1, and the 15 and make that a 3. And what I'd end up with is 9 over 8. Or, if I turn it back into mixed number format, 1 1/8. Again, if I didn't notice the simplification at this step and I just went 3 times 15 over 5 times 8 and then simplified, I'd still be fine. I'd still get the same solution. I just have to make sure I simplify it at the end. Second one here, two mixed numbers, so we've got to follow that process of making them improper fractions for both parts. So this first one here becomes 27 over 7. The second fraction becomes 36 over 5. These are the kind of numbers that you would initially look at diagonally and say, can I simplify these diagonally in any way, shape, or form? The unfortunate thing with this is I can't with these numbers. So I then have to do the calculation itself. Performing that calculation will then give me 927 over 35 as a mixed number. That then becomes 26 and 17 over 35. So again, I could have it in either of those two formats. We just have to look at what the question asks us for. That one there's a much more complex one with bigger numbers, but you'll notice the steps are the same. The steps don't change. It's just the numbers that change within it. Bear that in mind. It's a fairly straightforward process. We've given ourselves this skill and we have to make sure we follow the rules. Firstly, we said change the word of into a multiplication. If it appears there, change it into a multiplication. We then make sure we multiply the numerators and we multiply the denominators together. We always simplify. That second step was when we were looking at mixed numbers. We always turn the mixed numbers into improper fractions first. Key thing at the end, check how the question wants the format of the solution. Does it want mixed numbers? Does it want improper fractions? Or does it not care? If it doesn't care, we can leave it how we want. Remember, think smart, solve fast.